So a couple of things. There at the beginning of this unit, which I don't know, it was like a week ago or a week and a day ago or something like that. It feels like forever ago. We talked about the properties of acids and bases. There was a lesson or a lecture that went along with that. And if you don't recall, you may want to go back and review that. Also on Google Classroom, and I'll try to move it back up to the top, there is a Quizlet about the properties of acids and bases, or a quizzes or something that you can practice for tomorrow, because this is good. This could potentially be a really easy couple of points to get as long as you remember the properties of acids and bases. So a substance that will release OH in water, anything that has OH in it, we've always talked about being a base, so that's going to be our base. Having a sour taste, that will be an acid, and will change the color of an indicator. So in this case, this is a good example of both. One of the properties of acids and properties of bases is that they will definitely change the color of an acid-base indicator. But when we did our lab on Tuesday, what appeared to have happened is that the phenolphthalein, the thing that you put 2 or 3 drops of in, the acid didn't seem to do anything to it, but the base appeared to do something to it. But that's not always true. Both acid and base can change the color of an acid-base indicator. And a substance that will accept a hydrogen from another substance, this one is also going to be a base. Okay. So a substance that gives up a hydrogen would be an acid. Substance that accepts a hydrogen would be a base. Other things, this could be, So I don't know. Those are just some of the properties of acids and bases. There's about 5 properties of acids you should know, and about 4 properties of bases you should know, and they are all covered on the Quizlet that, again, I'll try to push up to the top so you can practice it. So that was the first thing that we talked about. And then the second thing we talked about was the range of pH and what it tells you about whether or not a solution is acidic or basic. So one of the things that we talked about was that if a solution is acidic, it has a pH range from 0 to like 6.9. And if a solution is basic, it has a pH range of like 7.1 to 14. So in the case of the first one, if a solution has a pH of 12, is it acidic or basic? Well, then that would be considered basic because it's greater than 7. And if the solution has a pH of 6, is it acidic or basic? Then this one would be acidic because it's less than 7. So the other thing that we can remember is that if it's neutral, it has a pH that's equal to 7. Okay. And then the last thing was a calculation that was similar to the lab calculation, but maybe not quite as involved, because I've given you all the things in the appropriate units, so you didn't have to change things from milliliters to liters. But this is definitely going to be a set of calculations that you're going to have to be able to do. So if I was doing this calculation, first of all, I'd have to recognize what my acid and what my base are. And I can see that my base is the NaOH because that has the OH in it. And the acid is the other reactant, usually because it starts with H+. So the question is asking me to determine the molarity of the NaOH if 0.0116 liters of 3 molar H2SO4 is neutralized with 0.025 liters of base, NaOH. So in this problem, the first thing I'm going to do is I'm going to find the molarity, or not the molarity, that's silly. I'm going to find the moles of acid. And I'm going to do that by using the molarity formula, right? So if molarity is equal to moles over liters, In this case, we know that the molarity of the acid is 3 molar, and we know that the volume of the acid is 0.116 liters. So I'm going to take 3.0 molar. I'm going to be looking for moles, and I'm going to take these 0.0116 liters. I'm then going to go ahead and solve for moles. In this case, I'm going to be multiplying both sides by 0.0116. And I get the number of moles to be something like 0.0348 moles of H2SO4. The next thing that I'm going to do is I'm going to convert moles of acid to moles of base. So convert moles of acid to moles of base. And we're going to do that by doing a stoichiometry calculation. But it's really going to be like a one-step calculation like that. Okay. So I know the moles of acid in this case is going to be 0.0348 moles of H2SO4. Let me clean that up. And in order to do that, I need to know the mole ratio of the acid to the base. So again, we've already identified which is which. So hopefully that I can see that it's 1 mole of H2SO4 for every 2 moles of NaOH. So I'm going to set this mole ratio up so that moles of H2SO4 cancel out. So I'm going to put my 2 moles of NaOH on the top and my 1 mole of H2SO4 on the bottom. And then I'll calculate the value of that. So I'm going to take the 0.0348 times 2, and the moles of base would be equal to 0.0696 moles of NaOH. And then the last thing I'm going to do is I'm going to find molarity of the base. And I'm going to do that by using the molarity formula, which is moles over liters, right? And what we know about the molarity of the base is that, or about the base itself, is that you had 0.0250 liters of sodium hydroxide. So, and you just calculated the moles to be 0.0696 moles. So I'm going to take that and I'm going to divide it by the 0.0250. And it looks like I get a molarity that's equal to 2.784. Looking at sig figs, I should probably have about 2 sig figs. So the final answer will be molarity is equal to 2.8 molar NaOH. So those are the steps that you would need to go through tomorrow on the real quiz or the not practice quiz. It's just 3 this time. It won't be the multiple before. And you have to take care of sig figs, and they should be somewhat organized. So that kind of sums up what your quiz is tomorrow. What your quiz tomorrow is going to look like. Clearly, it won't take very long. Any questions? All right.